Hi everyone. Today we are going to solve this question. This is our first questions. This was asked in 2077 with 6 marks. State Rolle's theorem. Interpret it geometrically. Verify Rolle's theorem for the given functions in the interval. This. Now what is the statement of Rolle's theorem? According to Rolle's theorem, for a function f defined on this interval, on closed interval, so that function is continuous in that interval and function is differentiable in open interval. And third condition is functional value at extreme points. That is, function value at x is equal to a and function value at x is equal to b both are equal. If these three conditions are satisfied, then there exists at least one real value c in the open interval this, so that the derivative of these functions at this point x is equal to c becomes 0. This is the statement of Rolle's theorem. Another Lagrange mean value theorem. These two theorems are very, very important from the examination point of view in NEB board. And another part is interpretation of Rolle's theorem. What is geometrical interpretation of Rolle's theorem? According to Rolle's theorem, the first condition is the function is continuous in the given interval. That means the function takes always a finite value for every value of x in that interval. That means there exists no breaking on the curve, and second condition is the function is differentiable in the open interval. Differentiable means derivative exists. Derivative can be obtained, right? That means derivative means the physical meaning of derivative is slope of tangent, right? Or the orientation of tangent, measure of orientation of tangent, that is derivative, right? So differentiable means here at each and every points lying on this interval a to b, at every point we can draw unique tangents. And third condition is functional value at extreme points are equal. That means fa is equal to fb. That means the height from the x-axis along y-axis up to the curve at the end point of the curve in that interval are equal. This height and this height or y coordinate are equal. And then there exists at least minimum 1 points. There may be more than 1 points, but at least 1 point exists. See here in figure, there is a point P at which the derivative is 0. Derivative 0 means the orientation of tangent line, that is horizontal. It makes angle 0 degree with the horizontal. It is parallel with the horizontal. It is parallel to the x-axis. And second curve here, this this is curve. This is a point P, and at which the tangent is horizontal. That means its derivative is 0. So there exists at least 1 point at which the tangent drawn is parallel to x-axis, parallel to horizontal. There may be more than 1 points. Let us consider graph like this. This is a y, this is x. Let us say this is a graph. You are observing here. This, let's say this point is A and this point is B, and at this point this is x is equal to A and at this point x is equal to b. How many points are there at which if we draw the tangent they are horizontal? If this functions this function if this function satisfy all the three conditions of Rolle's theorem, here at x is equal to a and x is equal to b, y value are same, and this is continuous and this is differentiable, all three conditions are satisfied, then how many points do you see in this graph at which we can draw horizontal tangent? This peak, let's say p, at this point we can draw horizontal tangent. This is horizontal, and at this lowest point, let's say this is a q, at which if we draw tangent, that is horizontal. We can draw a tangent that is horizontal, and this point, this is r, let us say. At this peak, if we draw tangent like this is horizontal. We can draw horizontal tangent. There are 3 points at which the tangents are horizontal. Here exist 3 points, but in these two graphs, only 1 point I have shown. Right? Okay. This is significant. The physical significance of geometrical significance of Rolle's theorem. The third part is what? Verify Rolle's theorem for these functions in the given interval. And here the function is this, and interval is a comma b, that is -1 comma 2. A is -1, b is 2. Rolle theorem, to be valid, the function must be continuous in the given interval -1 to 2, and it must be differentiable, and it takes equal functional value at extreme point, right? If so, there exists at least 1 point c. Okay, first we check the above conditions. Condition 1, for condition 1, this is the polynomial, takes always a finite value for every value of x, so it is always continuous, right? First condition is satisfied. First condition is satisfied. And second condition, differentiability. Difference, whether it is differentiable or not in this interval. Here I have some closed interval, but it is not closed. It is open interval, right? Correct it. Differentiating fx, then we get this value 2x minus 1. This is the derivative. This is a polynomial, and this exists for any value of x. It is also differentiable in this interval, right? So second condition is also satisfied because here the derivative exists. Derivative has a finite value. And third condition is functional value at extreme point. Checking at x is equal to a, that means x is equal to -1. Functional value takes value 0. At x is equal to 2, b is equal to 2 here. F2 is equal to 0. Here at extreme point, the functional values are same. Hence, third condition is also satisfied. That's why it satisfies all the conditions of Rolle's theorem. If so, then there must exist at least 1 point. At least 1 point in the given interval, given open interval. That is -1 to 2, right? In this interval. Derivative is here f dash x is equal to 2x minus 1. C is the value of x in this interval. If we put the value of x in f dash x, then here at x is equal to c, f dash c is equal to 0. That is 2c minus 1 is equal to 0, 2c is equal to 1, c is equal to half. Does this value of c lies in the given interval, given open interval? Yes. From -1 to 2 in this interval, this half value 1 by 2 lies in. That's why Rolle's theorem is valid, verified.